Hey guys, my name is Samira Syed. I'm currently pursuing my BE from Sri Venkateshwara College of Engineering. My USN is 1BE23CS150. Today, let's look into the topic of F distribution in statistical inferences. The content of our discussion today will include an introduction, characteristics of F distribution, a formula, a visual representation, applications of F distribution, and limitations of F distribution. What is F distribution? The F distribution is a statistical distribution used to compare variances named after Ronald A. Fisher. It is used in key methods like ANOVA, which tests differences between group means. Also in regression analysis, where it is used for evaluating model significance. It is positively skewed and depends on 2 degrees of freedom, which is a numerator and a denominator. The F distribution helps determine if observed differences are statistically significant or due to chance. Characteristics of the F distribution. First, we have the asymmetric shape, the non-negative values, then we have degrees of freedom, we have dependent on sample variances, hypothesis testing, and right tail distribution. So what is asymmetric shape? The F distribution is positively skewed, which is nothing but right skewed. The skewness decreases as the degrees of freedom increase. Then the non-negative values, the F distribution only takes values greater than or equal to 0. Degrees of freedom, it is defined by 2 degrees of freedom. D1, which is numerator degrees of freedom, and D2, which is denominator degrees of freedom. Dependent on sample variances, it arises as the ratio of 2 independent chi-square distributed variables divided by the respective degrees of freedom. Used in hypothesis testing, commonly used in ANOVA, analysis of variance, and regression analysis for testing equality of variances or model significance. Then we have the right tail distribution. Most of its probability mass is concentrated in the right tail, and critical regions are often found in the upper tail. The formula for the F distribution is F equal to S square 1 by D1 whole divided by S2 square by D2 whole, where S1 square is nothing but the sample variation of the first group, which is nothing but the numerator, and S2 square is the sample variation of the second group, which is nothing but the denominator. D1 is degrees of freedom associated with numerator, and D2 is degrees of freedom associated with the denominator. Here is a visual representation of the F distribution curve in regards of density and velocity. Now let's look at the applications of the F distribution. The F distribution is commonly used in statistics for comparing variances and testing hypotheses. Key applications include analysis of variations, which is just the extension of ANOVA, a term you would have heard earlier in this presentation. It is used to test whether the means of 2 or more groups are significantly different. The example for this is comparing exam scores from multiple teaching methods. Then we have the regression analysis, which is used to test the overall significance of a regression model. Example for this is determining if independent variables in a regression model predict the dependent variables. Then we have testing equality of variances, which is used in our hypothesis testing to compare the variation of 2 populations. An example is checking if 2 manufacturing processes have the same consistency. Then we have MANOVA, whose extension stands for Multivariate Analysis of Variance, extension of ANOVA to handle multiple dependent variables simultaneously. Then we have model comparisons, comparing nested models, example reduced versus food models, to determine which fits the data better. The F statistic forms the basis of all these applications, helping determine whether observed differences are statistically significant. So these are some of the applications of F distribution among many more. So let's head ahead and look into the limitations of F distribution now that we're done with the applications. The F distribution has several limitations. Some of them include non-negative values, asymmetry, dependence on degrees of freedom, sensitive to outliers, limited applications, and requirement of independent and normally distributed samples. So what are non-negative values? And what do they mean in F distribution? The F distribution is only defined for non-negative values, which means it is only defined for values greater than zeros. It cannot model data with negative values. Asymmetry. It is not symmetric. It is skewed to the right, especially for small degrees of freedom. Dependency on degrees of freedom. The shape of the distribution heavily depends on the degrees of freedom. There are 2 degrees of freedom in the F distribution curve, which is the numerator and the denominator, which must be positive integers according to the first limitation, which is non-negative values. Then we have sensitive to outliers. What does that mean? Since the F distribution is used to variance ratios such as ANOVA, it is sensitive to outliers in data. Limited applications. The applications of F distributions are very limited. They primarily apply to comparing variances between samples or in regression models. It is not suitable for modeling general data distributions of any kind. The last of the few limitations I'd like to discuss are the requirement of independent and normally distributed samples, which means for valid results in the hypothesis testing, the underlying data should be independent and normally distributed, which is often difficult to ensure in practice. So these are a few limitations of the F distribution. And we end here with our presentation. Thank you all.